In this lesson we're going to look at the carboxylic acids, and as with the alkanes and the alkenes and the alcohols, the carboxylic acids form a homologous series. Let's quickly review again what that means. Firstly, that they have similar chemical properties as you move along the group, and they have similar chemical properties because they possess the same functional group. In the case of the carboxylic acids, this is called the carboxyl group, which looks like this, either COOH, that's the chemical formula for it, and its structural formula is C double bond with oxygen and then OH with single covalent bonds between the carbon and the oxygen and the hydrogen. Okay, so this group dictates its chemical properties. This group is able to ionize in water like that to produce hydrogen ions. It does so weakly, so that makes it a weak acid. So with regard to the chemical properties of the carboxylic acids, obviously they are acids, they are weak acids. Okay? They form weak acids when dissolved in water. And the next important point with regard to a homologous series is that the members of the series all possess similar physical properties. So as we move down that series, there are small changes in the physical properties each member. So for example, they have similar melting points and boiling points. Now, the melting points and boiling points of carboxylic acids are higher than those of the alcohols, and there's actually an interesting reason for that, which I shall now explain. Now, ethanoic acid has a boiling point of around 118 degrees Celsius, whereas its equivalent in the alcohols, which is ethanol, has a boiling point of 78 degrees Celsius. Now, if we have a look at ethanoic acid, as with all the carboxylic acids, the carboxyl group tends to be polarized. So what happens is that the negative charges tend to accumulate around this double bond here in the oxygen, which leaves the OH group positively charged. And so what happens next is that the ethanoic acid molecules tend to pair up to form what is called dimers. So what I'm going to do is I'm going to rotate this molecule around by 180 degrees. You'll have to forgive me because that means that the carbon atoms are going to be the wrong way round, but you'll get the point. And so the negative and positive regions of each molecule will be attracted to each other. Now what is formed is not strictly speaking a molecule, it is what we call a dimer, which behaves as if it were a larger molecule. Okay, with a larger surface area and consequently larger intermolecular forces, or van der Waals forces. And that will result in the ethanoic acid having a higher boiling point than ethanol, for example, the formation of this dimer. Now, the other important property of the carboxylic acids, or at least of the first four members of the family, is that they are very soluble in water. And that's because this carboxyl group is a polar group, as we've just seen, and therefore it is soluble in water, which is a polar molecule. Now we should also mention that this solubility decreases as we move down the group. As we've already emphasized, that's what we'd expect because this is characteristic of homologous series, that there are small changes in the physical properties as we move from one member to the next. So the solubility also changes as we move from one member to the next in the series. Now finally, the characteristic of a homologous series is that it can be represented by a general formula. And so to do that, let's just look at the first three members in the group. And the first member of the group is methanoic acid. Then after that we have ethanoic acid, then propanoic and butanoic acid. Okay, so we'll write the chemical formulas for each. In the first case, the methanoic acid is written H, and then we keep the functional group intact in each case, so that's HCOOH. then CH3, COOH, then C2H5, COOH, and then C3H7, COOH. And then to see the general formula for this series, well, let's start off with ethanoic acid. You can see for the carbon we have 3 hydrogens, then 2 carbons 5, so we can write for each carbon there for every n, so we can write for every n carbon atoms we have H and then 2n plus 1 hydrogen. So in this series, the first member of this series will be n equals 0, okay, which will give us, and then we'll put on the, and then to that we'll add the functional group, which is COOH. You do not need to do this in a different color, I'm just doing that for emphasis. So the first member in this series has the value of n equals 0 in this case, which is methanoic acid, so that will give us so for example, butanoic acid, where carbon is 3, we're going to have C3, and then 2 times 3 plus 1 is 7, H7, and then COOH. The first member of this series will actually be n equals 0, not n equals 1, which will give us HC008, which will give us HCOOH.